Hello. Oops. Hej. Så, mitt namn är Jerome. Tyvärr kan jag inte tala svenska. So I should continue in English because I exhausted all the words in Swedish that I knew. Well, knew. So who am I? So I'm Jerome. I work for Docker, and I've been working for Docker for 5 years, soon 6 years. So that's great because I'm older than Docker itself, because I joined Docker before Docker was Docker. I joined Docker was still .cloud. .cloud was platform as a service. We were running containers. We were running containers for people in production at scale. It was pretty painful, so I'm glad at some point we stopped to just concentrate on the containers themselves, because that's way more exciting. But back then, we were doing microservices without calling that microservices, because I don't think that the word microservices was there yet. But we had many little things to manage those containers. When we handed over the platform, we had 100 microservices to deal with those containers. There was something to create containers, something to build code, something to put the code in the containers, something to detect when a container goes out of memory, something to gather all the out-of-memory errors and aggregate them for the end user, something to, and so on and so on and so on. Even when we did the private beta of .cloud, we had one microservice that we could query with our RPC thing to send invites through that. So instead of having like the big Excel spreadsheet and put people in the Excel spreadsheet and then send invites, we had a microservice to send the invites. That's how microservicey we were, without even knowing that we were doing it. We are also using this idea of you build it, you run it, which means that instead of having a team of developers that then throws some code above the wall and then a bunch of people running that code and cursing them for writing code that doesn't work, when you've wrote something, then you had to run it and you were on call for it. Since we're a rather small team, it boiled down to everybody writes everything and everybody is kind of on call on everything, which gives you a really strong incentive to write code that actually works. So that's the past. Now in 2013, .cloud became Docker, and so since then, a bunch of things happened. So my agenda for today, I want to talk about what's new in Docker in general. I want to talk about what's exciting, which will be extremely subjective, because what I find exciting is maybe not what you will find exciting, so I do apologize in advance for that. And then I will talk about what's next, so what's coming soon in Docker ecosystem. So first, what's new? Well, a really quick kind of story arc. Since recently, it was the 3rd birthday of the Docker project. So since 2013, since those 3 years, for me, the biggest change, well, not really, but kind of the big label, is that back then, when we talked about Docker, we just talked about the container engine. When we said, oh, I installed Docker, we mean the thing that we call today the engine. So the thing with which you can do Docker run, Docker PS, Docker build, and so on and so on. Today, when we talk about Docker, we say the Docker platform. So the Docker platform, it's not only the engine, but also all those other tools that go with that. So machine, so that you can create VMs with Docker on them. Compose, so that you can take a bunch of containers and connect them together in a more complex application. Swarm, so that you can take a bunch of Docker engines and put them together to make a cluster. Docker Cloud, Docker Data Center, and many other commercial products, because yeah, between 2013 and 2016, we made some kind of financial forecast and say, okay, if we continue like that, we're going to run out of money, so we need to also sell stuff, which is why you can see an increasing trend in Docker Inc. now in trying to sell you things. I'm sorry about that, but at some point we have to make money. All right, so now what's new in Docker, like in more recent thing, not just like the 3-year story. So this is relatively new. It's not like the newest. I'm going to talk about the newest in a bit, but this is like maybe 1 month old, something like that. Engine 110, so that's the latest stable release of the Docker engine. One of the biggest thing in this release was the big push on security. User namespaces arrived in stable release, so now you can use those user namespaces. If you haven't heard about user namespaces before, user namespaces are a mechanism to map UIDs in containers to different UIDs outside of containers. This means that you can be root inside the container, and that can map to a non-privileged user outside of the container. So from a security perspective, that's great. That being said, if you want to enable user namespaces, it's not as easy as you would think. You have to enable an option in the engine. When you will restart your engine, then you will notice that all your images have disappeared. In fact, they haven't disappeared, but there are two stores of images, if you will. One when you use the user namespaces, and another when you don't. This is for obscure UID mapping reasons, because basically once you have user namespaces, all the files that did belong to root now have to belong to somebody else. So to avoid a migration, which would be a fancy word for shun on all the files, we just decided to have a different directory where we would put the new images using user namespaces. And also, if you expect user namespaces to magically work for everything, I have some bad news for you. When you enable user namespaces, there are some features that won't work the same or even won't work at all. For instance, host networking, sharing the network stack between containers. User namespaces don't get us there yet. There are a few things that you need to change if you want to use user namespaces. So I would say that the idea is to provide user namespaces for people who are extremely security conscious. Like if you want to have this kind of big checklist because you want to have bulletproof containers, then you enable user namespaces with a bunch of other things, and you will lose a few features. But in the long run, we hope to be able to have all those features available with user namespaces as well. But as often, security is a matter of compromising between features and security. So here, you gain some security and lose some feature. SecComp. SecComp is, so that stands for Secure Computing. It's a little bit like IP tables, but for system calls. So it's a mechanism so that you can control which system calls are allowed to a container. So normally system calls are like opening a file, creating a socket, seeking in a file, things like that, keeping the screen on. Yeah, that's not a syscall, but that should be. So with secure computing, you can define whitelists and blacklists of those system calls. And this is great from a security standpoint because the system calls are at the border between the containers and the kernel. So you want to really control thinly and accurately what's going on here. Docker update. So Docker update, this is not something to automatically upgrade the Docker engine or something like that. Docker update is to dynamically change the resources allocated to a container. You know, if you start a container with docker run -m 1 GB to give it 1 gig of RAM, then you can change that dynamically with Docker update. There is a daemon config file, so there are a few options there. You can't completely reconfigure the engine yet, but we hope to eventually get there. But you can already change a few things without having to do a full restart of the engine. There is also some experimental support for multi-architectures, which means that we get even closer and closer to being able to seamlessly run stuff on Raspberry Pis, on Windows, and other architectures. Networking. So in Docker Engine 1.9, the naming in the network is using plain entries in /etc/host. When you create containers and put them on a network, or when you use links, then you can give names to your containers, and those names end up being entries in /etc/hosts. In the engine version 1.10, this is now a dynamic DNS server, which is using something that you might know as views or split horizon, which just means that each container gets its own private view of the DNS. So in a container, when you resolve the name DB, it could resolve to one IP address. In another container, maybe DB resolves to a different IP address. If you're using Engine 1.9, and you want to use overlay networks, you need to have a pretty recent kernel, 3.16. In Engine 1.10, enlarged the compatibility map to kernel 3.10, which is great news for people who are stuck on older kernels for stability, support, or whatever reason. There are a few other options on overlay networks, like now you can have isolated overlay networks, so each overlay network doesn't automatically come with a default gateway, and that's a feature that a lot of people wanted for a long time. You can now set the IP address of a container. So before, when people said, I would like to set the IP address of my container, we said, no, you don't want to do that. You just want to use port mapping or something. And network administrators were really sad about this. So network administrators can now be happy because you can just start a container with docker run --IP, an IP address, and it will allocate this IP address to the container. Push and pulls were improved, maybe especially if you are traveling a lot and you use 3G tethering, or if you have a really crappy Wi-Fi at home or something like that. Maybe you hate the fact that pushes and pulls were sometimes slow, would break in the middle, and so on and so on. This was improved a lot in Engine 1.10. Pull is now smarter. And push as well. For pull, now there is a download manager, so something that we had for FTP servers like 20 years ago, where it kind of figures out which layers you need in which order, and it makes sure to download first the layers that you will need first. I will try to demo that quickly. And parallel push, before when you would push an image, it would push the layers like one by one, slowly, making a pause like after each layer. Now it tries as hard as it can to push everything in parallel, so that pulls and pushes are much faster. Swarm 1.1, so the release notes, and when you see the changelog of Swarm after version 1, it's generally not super exciting because it's full of obscure things like improved node management, which means that it's really a huge a lot of small improvements on reliability, detecting when a node comes down, and also some operational details, like when you do Docker info on a Swarm cluster, it will tell you all the nodes that you have, and it will give you a short status for each node, like what is the last error that was reported by this node. So when you have to manage a cluster, that makes a big difference. But when you are just the user, you won't see really anything new here. Failover and rescheduling, so those are two high availability features. Failover is about Swarm itself, so when you have a Swarm manager to control your cluster, when that Swarm manager goes down, you need to spin up a new Swarm manager. Well, now you can have redundant Swarm managers, and the way it works is pretty simple. It will use a leader election using a key value store, so if you're using console, etcd, or zookeeper, it will use that. And when you talk to the active leader, it will directly control the cluster. And when you talk to a standby manager, then it will just transparently redirect your request to the active leader. So you can talk to any manager node, and it will transparently manage your cluster. Rescheduling is about failover, not for Swarm itself, but for the containers that you run in Swarm. So you can set a rescheduling policy on a container to say, I want that container to be restarted somewhere else if that node goes down. In other words, if I start my container on this machine and then that machine goes down, then Swarm will detect that and will be able to restart the container somewhere else. Compose 1.6, so the big change in Compose 1.6 is the fact that there is a new compose file format, and I will show that. You'll see it brings great things, but it's not more complicated. Compose can now deal with networks, volumes. This means that in Compose, you have a bunch of services, and now you can put the services on different networks. So you can say, this is my front network, my database network, the network where I have my Cassandra cluster, and so on and so on. And you can put containers on multiple networks. So basically, it's YAML-defined networking, and it's pretty cool. All right, so now what's exciting? So this is like just my kind of personal staff pick, and that's where I want to do small demos. I'm going to sit here. So first, I want to show smart pools. So I'm going to try to pull a big image, something like Kibana maybe. whoops, I want to talk to one node at a time, that would be better. And so what we can see here, okay, it already pulled out of it, so I'm going to try with another one, like Logstash maybe. What I want to show is that you will see, yeah, it pulls the first layers first and extracts them and then moves down. So it tries to be more efficient when getting layers and unpacking them. And that's a little detail, and it's not complicated, but it means that pulls are now much faster. Pushes as well. So let's see. I have a little application here. All right. So, okay. So I'm going to build an application using a. Whoops! Did I lose the Wi-Fi or maybe? Yeah, we're back. Okay, so I have like a little compose file here defining a bunch of services. And by the way, when I told you that compose file version 2 was not complicated, what I mean is that with compose file version 1, you would have this. And with version 2, you basically shove everything under a services section and you put version 2 on top and you're done. That's what it takes to migrate from compose v1 to compose v2. All right, and now I want to show what it's like to push to a registry. So I have a little script here that will build all those containers and then push them to a registry. But first I have to set the variable indicating where is my registry. All right, and that's it. So that was really fast because those containers were already pushed on the registry. But if you have used the registry before, you remember that even when all the layers are here, when you push, it will still take some time to say, oh, I have a layer to push the registry. And then it takes maybe a couple of seconds and you say, we already have that layer, great, let's move to the next one. And it does that for every single layer, for every single container. So if you have 5 containers with 10 layers and it takes 1 or 2 seconds each time, it means it takes 1 or 2 minutes, even if nothing changed. Here, I mean, I can rebuild and repush everything and it just took a few seconds. So little details, but it means that when you're in this dev cycle where you build and then you run and then you build and then you run, you have no excuse to go and get a coffee while it's building and pushing, but you can keep working all the time. All right, next thing I want to show, overlay networks. So I'm going to talk to my Swarm cluster. All right, so that's a bunch of containers. It's all about the network, the Docker network command. So the Docker network command lets me create and manage networks that will span my whole cluster. So here I have a cluster of 5 nodes. If I do Docker PS here, let's zoom a little bit. Yeah, I do apologize if this is not super readable from the back, but I wanted the full thing to fit in the screen. Here on the right in the names, you can see like node 1, node 2, node 3, node 5, 4, and so on and so on and so on. So I'm going, I had simulated a failure earlier, so I need to restart something here. Sorry. Great. Okay, so Docker network. What I can do with Docker network is that I can create a network. So for instance, I'm going to create the rainbow network because, yep, you can put Unicode in your network names. Perfect. And now I can do Docker run --net the rainbow --name. Let's pick a few colors like blue. And let's use -d alpine sleep. Alright, so I just started a container on this network. Now I'm going to start another. Let's say it's going to be green. And now I can do ping blue, and it actually pings blue. Ignore those 2 lines of warning. That's because I'm running a release candidate version of the engine, and so there are a few little things like that. And so now if I do Docker PS here, I can see that blue and green are on different nodes, like node 2 and node 3. So this lets you have some, I want to call that software-defined network, except that usually when we talk about SDN, immediately we imagine that extremely complicated thing when you have to pay a lot of money for specialized equipment, you have to acquire companies for billions of dollars to get something that maybe eventually works. While here, the most complicated thing was the shortcut to get the emoji keyboard to get that rainbow. But other than that, it was pretty easy. You can put containers on multiple networks, so you can have a single container that can be a kind of a gateway between networks. You can dynamically connect and disconnect those networks. And here, my Rainbow network is using the overlay driver, but there are other drivers, like if you want to interface with VLANs or with specialized network equipment, you can do that and use network plugins so that your network is backed by anything you like. Is there anything else I want to show about networks? No, I think that's great. I mean, Unicode, the Rainbow network, how cool is that? Oh yeah, I will take this opportunity to show net aliases. So if I go to, okay, let's say I'm going to stop this blue container, docker rm-f blue. Yeah, I'm still in my container. So I made a typo, and then, yeah, there we are. So I'm going to start the container, but with a slightly different option. I'm going to give the option net alias. So net alias blue dash t id. Okay. Whoops. No comment specified. Yes. Actually, you know what? I'm going to start a web server. That's going to be way better. Docker coins. Sure, maybe. Or I forgot to put it in the background. Okay. Perfect. Now I'm going to so in the other window here, docker run --net rainbow -ti sh, and I'm going to do ping blue. All right, I'm pinging blue. Fine. Now I'm going to start another container, also with net alias blue. So now in my Rainbow network, I have 2 containers that have the blue net alias, and so all right, it always gives me the same. So pk --date drill. So this is a little DNS resolver, and it tells me, yeah, blue has 2 entries like 10.012, 10.014, and if I use curl. Here it tells me that I have one container, so I'm going to zoom a little bit so everybody can see it. I have a container here on EEC, etc., etc. If I curl the other one, it's a different container ID. And if I try curl blue, so see, you can wonder, like, okay, so that's kind of weird because when I do my DNS query here, I get multiple records. I even get those records in different order each time. So why, when I do ping blue or curl blue, why do I always get the same container? This is because there is an RFC, and I forgot the exact number. It's something like 3884 something, which says that normally if you are a well-behaved resolver, you should sort the records when you receive them. And so that's why, even though Docker sends me all the containers that have the blue network alias, it always connects to the same one if I don't do something special client-side. To complete the demo, I'm going to start one more container with the same network alias. And now I have a 3rd entry here. So this means now that if you want to implement some kind of load balancing, you can do that client-side or you can have a container that will take care of that. So that's going to be a slightly more complex demo. I don't know if that will exactly work, but let's try. I'm going to start a load balancer container. Let's name it LB. I'm going to use a load balancer that I've wrote, which is based on HAProxy. This and dash the option, and then I'm going to pair it with another container which will watch DNS entries basically, and that will automatically generate the configuration for the load balancer. So this little watch DNS container will repeatedly check the DNS entries, and when they change, it will reconfigure the load balancer. All right. So that's kind of live demo. So I hope this will work. Maybe. So this one, okay. I forgot to give options. Yeah, I have to tell it on which port it should listen. And hello Wi-Fi. So the name will be blue and connect on port 80. Hello. Okay. Okay, so now if I'm here, when I do curl LB, so I'm talking to the load balancer, and now when I do curl LB, I get different entries. And if I remove some of those containers, let's see. So let's remove 955. So see, at this point I get responses from 05 something. Well, from those 3 containers, I'm going to remove one of them. So now when I do drill blue, I only get 2 records, and when I use curl, I just get responses among those 2 containers. So that lets us implement. Oh, that was not that. But thanks. No, so that lets us implement some load balancing from the container itself, kind of easily. I felt a little bit nervous doing the demo because that's the first time I do that live, but everything works fine. Well, proof. All right. Scaling and Docker and console in Docker. That's a feature that I really like on the ops side, because so on this cluster that I'm using here, I have 5 nodes, and I'm using overlay networks, and I'm using failover and a lot of features like that. And so I'm using console as a key value store. It is probably super small, so you can't really see it, but console is running in containers on the cluster. So my swarm cluster of Docker engines relies on console, and console itself is running in Docker. So when the cluster is running, everything is fine. My engine connects to console is in a container, but that's okay. However, there is a kind of chicken and egg problem. How does this story begin? How do you start console first? Well, you can't, because console is in the container, so if you don't have the engine, you can't start console. Okay, so you start the engine first, but the engine is using console, so you need console or what? So it works by starting the engine, indicating to the engine, you should use console on this address and port and everything, without having console. And the engine is kind of lenient, it's kind of nice with us. It will try to connect to console, but if that fails, instead of bombing out and saying, no, I can start because no console, it will just, the features that require console will not work, but everything else, will work fine. So this means that at first I start my engines, and I can't use overlay networks, and I can't use all the swarm discovery and everything, but I can still start my engines. Then I can start console in my engines, and then as soon as console is running, all the features are available. All right. What else do we have? Compose v2, I show that briefly. But I want to show a more complicated Compose v2 file because I say, okay, we can do a YAML-defined networking. So YAML-defined networking looks like compose file. Oh, it's the other terminal maybe. I think it's that one. So let's zoom a little bit. So I still have my services section here when I have a bunch of services. I have load balancers. I have this DNS watcher thing I was talking about. And in the beginning I say I want to have two networks, Hasher and RNG, and then I put my containers in those networks. So if you have never seen a compose file, this probably seems like a YAML nightmare, like you feel like you're back in the Tomcat days when you had to write 800 lines of XML to add dependency to your project. But just to put things into perspective, this is 67 lines of YAML, and it defines an application that has 5 services, that has 3 networks, that has, well, 5 services plus services, so it's more like 10 services. So that's still pretty small, and once you know that syntax, it's pretty readable, I promise. And maybe I can try to run that on this cluster. So compose file to this, then I can do docker compose up. So now when you docker compose up, instead of just starting containers, it also creates networks. Okay. Great. And now let's see where my application is running. So I have a little web UI. I can go to that web UI. So this is the Docker Coins app. This is the app that I use for all my demos and workshops and everything about Swarm. And the whole point is to learn how to scale the application. And the first step is pretty easy because the application is based on a background worker, so you can scale that worker. So here I'm just like cloning one container into 10 copies, and as soon as it is done, you can see the graph here spiking up. However, now we have another service that is the bottleneck for our application, so we have to scale that service as well. And so the first scaling command here was really easy and simple. It's just take that container and make multiple copies of it. There is nothing special, it's just a background worker, so you just fork multiple containers and that's it. However, when we do that one, more interesting things are going to happen, because this service is a web service. So when I do that, not only it adds multiple copies of the service, but there is a load balancer that notice, oh, you have more backends now, and so it dynamically reconfigures itself. And that's the other peak that you can see here. And so if we look at like this, it will tell us, okay, at first we had no backend, then we had one backend, then we went from one backend to two backends, then two backends to three backends, and so on and so on. Right. So that's what Swarm stuff looks like today. I'm done with the demos because I can start to see some people falling asleep. So Docker moves fast. So I want to talk about what's next. So what's next? Usually when I'm at that part, I do some kind of Nostradamus style predictions, like I think we're going to do this, and people usually believe me because I work at Docker, but really I have no say and no power in this. I mean, I'm currently in this extended trip in Europe, so when I was in San Francisco, I could at least say, well, yeah, I can walk up to the desk of the person working on networking, and I can ask them if they could implement this feature, or I could try to bribe them or threaten them or something. But no, I can't even do that. So when I do predictions, usually it's just like I say, it's just like, I'm not sure, who knows. However, here I'm pretty sure about what I'm going to say because all that stuff is in RC right now, like Earliest Candidate. So And this is a public RC. When we do release candidates, it's not like for internal use or something. In that case, it's general public. So engine 111, the big change in engine 111 is invisible. It's the switch to containerd. So it's invisible because for most of you, it won't change anything, but under the hood, it's huge. It means that when you will start a container, instead of directly having the engine manipulating C groups and namespaces, and now the engine will talk to containerd. So containerd, it's a little bit like, well, it's like the Docker engine itself. If you remove the API, if you remove the build system, if you remove networking, well, you kind of remove everything except the stuff that basically runs the containers. And even containerd really doesn't run containers directly. It will use an OCI compliant backend. So for now, it's using runC, this little thing that we used in some cool demos in the past. Maybe you've seen the demo at DockerCon last year, where they were playing Quake 3 on a server in Singapore or Hong Kong, and then migrating the Quake 3 server to the East Coast and then the West Coast without stopping playing. So they move live processes. So that's what containerd is using. And the goal is to be able to use many OCI compliant backends, so it means being able to switch to, I think, like those Intel clear container things, or Rocket, or anything like that. This means that in the Docker engine itself, there is no Linux specific code anymore. Like it's now completely portable and generic. It will talk to containerd instead. Well, containerd will be specific, but the engine itself is now architecture agnostic. This means that the engine can be restarted and upgraded without restarting the containers, because you can restart independently the engine, but also containerd without touching the containers, because containerd was architectured from the beginning to allow that kind of trick. So that's great from an ops point of view now, when it's like, oh, upgrade Docker, oh crap, I have to restart my container. So that's a thing of the past. The downside is that Docker is not a standalone binary anymore. Before you could just like download the Docker binary and run it. Now you need Docker binary, and you will need this containerd and a couple of other utilities. So that's the price to pay. On the networking side, I mentioned that in engine 1.9 it was just entries in etc host. In engine 1.10, when you have multiple containers with the same network alias, Docker will pick one of them and return only that one. In engine 1.11, I completely forgot to show, but in my demo, obviously, I was running Docker 1.11.0 RC2, released like 10 days ago. And this is a fresh build of Swarm that I built just after landing in Stockholm this afternoon. In engine 1.11, now the engine returns all the DNS records so that you can do some client-side load balancing without requiring introspection. And I did the demo already, so we're good. In engine 1.12, maybe we will get some embedded load balancing. That's clearly the roadmap in the long run. We want people to be able to automatically get ways to load balance things without having to add extra containers like I did in my demo. Compose 1.7, I only started to play with that one, so I only noticed a few things. If you are a Compose user, the first thing that you will probably see is that now Docker Compose logs works like Docker logs. When you do Docker Compose logs, before it would like stream the logs continuously, while Docker logs is just show all the logs and exits. Now Docker Compose logs shows all the logs and exits, and you want to do Docker Compose logs -f if you want to follow those logs. Another improvement in logs is that now if you're using Docker Compose logs and then you scale up containers or add containers, Compose will automatically detect that new containers appeared and that it should show you the logs of those containers. Swarm 1.2. Rescheduling, so the thing to restart containers when a machine goes down, goes to stable. Here I want to tell a short story about simulating failures and also being embarrassed about that. When I started to test Failover in Swarm, so I had this 5 nodes cluster, and what I was doing is start a container with a rescheduling policy, and then I was rebooting the machine. and I was waiting for the container to appear on another node. And that didn't work. Instead, I would see the container show up on another machine, but it wouldn't start. The container was here, but it was stopped, it was created, but it was not running. So I started to complain to the Swarm team, like, what guys did you do? What's going on here? And it turns out that if you do reboot on the machine, you're doing a clean shutdown of the Docker engine. So the Docker engine will shut down all containers. And so when the node disappears, Swarm says, you have a container here that you want to reschedule on another node, but that container is stopped since you were doing a clean shutdown. So I'm going to move the container to the other machine, but I'm not going to start it because it was not started. So when you're simulating failures, make sure that you're simulating something that is really like a failure. As soon as, instead of doing reboot on the node, I did like a crash of the node, or I disable the network, or add some IP tables rules to isolate it, then instantly things work beautifully. So, yeah. Last thing I want to talk about is Docker Mac and Docker Windows. So Docker Mac is the successor of the Docker Toolbox. So the Docker Toolbox is this thing where it's kind of a big all-in-one toolbox. So when you install it, you get a VirtualBox, you get a boot Docker VM inside VirtualBox, you get the Docker CLI, you get Compose and Machine and all those things. Docker Mac is a normal application, so it's not a VM in VirtualBox, it's like a Docker app, and you install it to the application folder and you double click and magic happens. It's using hypervisor framework, so it's normally I had updated that slide, maybe. Yes, right. So Docker Mac is still using a VM under the hood. It's Moby, not Bobby, sorry. But that VM is no longer using VirtualBox. It's a normal USX app, so it's a little bit like QEMU in the sense that it's userland, but it will not be slow emulation like QEMU. It will use hypervisor framework, so it's kind of a little bit like using KVM on Linux. So for now, Docker Mac is in private beta, unfortunately. But we expect to have that available generally soon. And if you're really impatient to test Docker Mac, you can send me an email or a tweet or something, and I will try to get you on the private beta list. Some people were extremely angry about this private beta thing, like, why the F did you have this thing? Can't you just make the thing public and be done with it? The reason is that we know that there will be bugs. And for now, we would rather give out this private beta to a smaller number of users who are already power users and who we know that they will be okay with taking the time to file a nice bug report, and they will know, like, if they get an error, they will know if it's a problem coming from their Docker engine or some other container, and so on and so on. So that's the why of a private beta. I've been on the other side of private betas before, like, I want to use that stuff, just let me download it and be done with it. And so I was kind of unhappy about private betas, but now that I'm on that side, so on the side of the team making the product and having to do support, private betas are actually really helpful because they avoid having thousands, or in the case of Docker, not far from millions of users using your thing, and sometimes half of them don't really know what they're doing yet because they are just new users. And so if all of them file bug reports or are unhappy about the product, that's bad. So start with a small group and then you expand to everybody. That's all I got for today. Thanks a lot. If you have questions, I will be more than happy to try to answer them. Yeah.
Can you elaborate a bit more about Consul as a Docker container?
Can I elaborate a little bit more about Consul in a Docker container? Yes. So the way that my setup works is, let's see. I think it's better to describe it because a drawing would be nice, but I don't have one. So, Consul is started using host networking. So it's a Docker run --net host, which means that the Consul process has access to the network interfaces on the host. I could have decided to have like a -p this, -p that, -p whatever, -d, -p blah blah blah, and you need, I don't remember, 5, 6 or 7 options. I kind of decided to go easy and simple and say, okay, I'm going to give my faces to console because all my console nodes need to talk to each other. So it's easier to let them have access to that rather than kind of play games by putting console in the container and then making holes in the container so that console can get out. So that's one thing. The second thing is that then the engine is set up to use localhost colon 8500 as the console endpoint. So basically each engine connects on console running locally and each node is running a console agent. The first node is started with dash bootstrap and the further nodes are started with dash join. So then it's kind of normal console stuff. The only fancy thing I did is that in console, if you have multiple network interfaces, and in Docker you have multiple network interfaces because you have ETH0 and Docker 0 and maybe even more, you have to tell console which IP address to advertise. And so what I did is that I have a little custom console image, which the only thing it does is that it looks up the IP address of ETH0 and it adds the advertise flag automatically. I'm pretty sure that in a future version of console this won't be necessary anymore because console will allow us to do dash advertise ETH0 instead of dash advertise IP address. And if you want more details about that console setup, you have multiple options. There is the cheap option and then the easy option. The cheap option is to go to a container.training and there will be links like and the one that is interesting is Advanced Docker and Orchestration. And there will be a number of slides. And if you look towards like slide 260 or something like that, there is something about console. The easy option is to come to the workshop that we're doing tomorrow. I think there are a few seats available. But all the materials are available, yeah. Yes?
Following up on that question, is console going to be the preferred key value store for Docker?
Is console going to be the preferred key value store for Docker? By me, yes. Generally, no. No, what I mean there is that I use console in almost all my demos and tests and everything just because we can either say that I'm lazy or I don't have the time to learn how to really know very well all of them. So at some point I decided to use console. But for now, we are committed to support console, etcd, zookeeper, and if something else, if another equivalent comes up, we'll use it as well. But internally at Docker, we treat all of them the same way. I have a personal preference for console, but that's just me, Jerome, not Docker, the company.
You run console cluster or one specific bootstrap node?
So in this demo, did I run a console cluster or did I bootstrap a specific node? I bootstrapped one node and then had the other nodes join the first node.
Another question?
Yeah.
So is it possible to install specific Docker version? Let's say I need only 1.9, not the newest version. So is there a way to specify that this is the specific version that I need to install in a host, Docker host?
So the question is, can I specify an exact version to run on my host, like Engine 1.9?
Yeah.
You mean like if you deploy on a host with Docker machine, for instance, or?
No. Let's say that
okay.
I'm going to have to install it.
All right. Let's say I have a Docker host somewhere, and I say, okay, I want to get that exact version. Yes, it's possible. So, for instance, so I would have to double check because I haven't done that for a while. But if you are using Docker's upstream package repositories, I think we keep all versions. And so if you do apt-cache show Docker, it will show you all the versions. Well, Docker engine, it will show you all the versions available, and you should be able to do apt-get install Docker engine equal the version that you want. I believe we keep all of them because, some people need that. Yeah.
I have a question regarding the security of the Docker. What do you see compared to like a hypervisor or, say, VirtualBox or VMware? Which one is more secure?
So the question is, what about the security? Like which one is more secure? Is that between, you said,
between Docker and, let's say, like a virtual machine?
Oh, so is it more secure to run in a container or in a VM? Both. I think today we need both, because today let's say yesterday, before containers became so popular and so on, we would run in VMs, for instance, and in a typical VM, sometimes you would have, let's say, a web server and then a worker to do like background processing for that web server, and maybe like a memcached or Redis cache, something like that. Now with containers, you can do the same thing, except each of those components will be in its own container. So you kind of step up the security a little bit. If you really say, okay, I can only pick one, like only VMs or only containers, well, then kind of good luck. But today, I think if you really want to be on the safe side, you need both, because it's the same. Like security is all about defense in depth. It's not should I do regular software upgrades or should I have a firewall? Well, you need both. So here it's kind of the same thing. Tomorrow, if I put something in production, I want to have VMs because I want the convenience of VMs. I want to if the kernel starts to misbehave or to manage my machines, I want VMs because that's so much simpler. But to manage my applications, there I want containers because that's also so much simpler for different reasons. So I want both. And from a security point of view, I think it adds up. I will get the benefits of strong isolation with VMs and plus the extra, let's say, inter-process isolation that containers will give me.
So there has not been a really major security breach with Docker?
Has there been major security breaches with Docker? There has been some vulnerabilities, like the one I remember really well was one about capabilities. So that was a while ago. There was a capability that would allow you to transform, if I remember well, to transform a path into an opaque handle and vice versa. And that capability basically lets you break out of the file system of a container. So once you break out of the file system of the container, you get access to the file system of the host, and from there you get access to basically anything you want. So that means that any container could break out. So that was pretty bad, but that was also pretty easy to fix. I think there will be security vulnerabilities with containers, some of them in the kernel, some of them in Docker. There will be security vulnerabilities with VMs, some of them in Xen or KVM, some of them in lower or upper layers. So we kind of need both anyway. Yeah.
So how do you plan to handle complexity? I mean, if you are moving to using containerd, which is going to run a number of different types of hosts, you're going to have security hosts, like multiply 3, 4, 5, I don't know. How are you going to handle this?
So the question is, how do I handle complexity if I have if I have VMs and containers, now I have multiple different hosts to manage, and
security-wise.
Yeah, security-wise, how do I keep track of CVEs? How do I upgrade? This reminds me a remark that somebody from Google made a while ago, explaining that they wanted to have something like that for them. The kind of weird thing with containers was, okay, I'm maintaining my host, and now I have to maintain the host and the container. I would like to use the same thing for the host and the container. And it took me a while to really have a good answer to that, because at first was like, wait. And so the answer for me is that the way we do security before the container age, so to speak, is a kind of matrix. Like, okay, you have many libraries, many applications, and it's a big multiplication, a big explosion of everything. Like, I have a machine with Node and Mongo and SSH and Nginx. SSH and Nginx will use the system's OpenSSL. However, Node and Mongo ship with their own OpenSSL. So if there is an OpenSSL vulnerability, I upgrade, but if I don't upgrade Mongo and Node, I don't get the upgrade. So it creates a kind of big explosion of versions, and we got kind of used to manage that, because okay, we subscribe to this mailing list and we have all those vulnerability scanners, and that's how we do it. Today, I think it ends up, instead of being this multiplication, it's more like an addition. It's like I have my host system, I have my containers, I have so my Mongo and Node and Nginx container, but each of those systems independently is simpler, and more importantly, they don't interact with each other. When I'm on a classic environment, I have a bunch of programs that depend on a bunch of libraries, and so I have those dependencies, and maybe I will update one library that will break another program. If I'm in containers, each environment is clearly independent. If I want, I can do atomic updates on the host. I can use CoreOS or Project Atomic or any of those systems like that to say my host is a read-only thing. It's super simple. It runs like 4.5 processes, and that's it. And then each container can have this strict minimum viable set of packages. I'm a huge fan of the Alpine Linux, which honestly before containers was really for something for weird people who said, I want to run all my things in 100 megabytes. Suddenly with containers it becomes great because like maybe you quickly start doing my demos, but each time I need a quick container, I use Alpine. 1 year ago I used Debian everywhere because I'm initially more a Debian person. But now when I need a container really quick, I use Alpine because it's smaller, because installing packages is crazy fast. And so when you use that in production, the security footprint is much lower. Like when you list the packages installed, even on a really small Debian system, you have like almost 200 packages. Well, Debian is a little bit less than 100, Ubuntu a little bit less than 200. Alpine, it's super small. So the chance that you have some vulnerability because there is that old PPP package that is still installed since 15 years, that thing goes away. So at first, from a security perspective, we're like, okay, how do I manage the containers? This is new. I need new tools. But once we will have those tools, we will have made a huge improvement over the previous situation. At least that's my opinion. One of the things that we are building is Nautilus. It's something that we announced at DockerCon Barcelona in November. And the really short version is that it's something that scans your images for vulnerabilities. So this means that when you need to make an audit, you don't need to SSH into all the machines and gather information and all that. You can do the audit just by looking at the images in your Docker registry. So that's a huge improvement over the previous situation. I don't know if that completely answered your question. Yes.
I was wondering, is it possible to run the load balancing example on 110?
Is it possible to run the load balancing example on 110? Yes, but it will be slightly different. When I was doing this demo on 110, when I scaled up or down, or when I added or removed backends, I would run a tiny little script that maybe 10 lines that will basically collect the backends and reconfigure the load balancer. But it had to be outside of the container. So now that thing can be inside the container, so everything can be, well, self-contained, if I may say. Yeah.
You happen to know the status of image signing?
What's the status of image signing? I don't know. That's. I mean, do you have a specific thing in mind, or?
When will I be able to sign an image when I build it and then verify it when I run it?
When we will be able to sign and verify images? As far as I know, that's already possible, but I have to confess that it's one of the features that I never tested. So, but that's a very good remark. So I can't really give a good answer now. But
I don't think it's really there, but I might be wrong.
I will give it a try, and in a future talk this year, I want to show that because that's a good point.
Isn't it what Notcher is doing?
That's what Notary is doing. I mean, I know the theory on it. Like, okay, so you have Notary that will verify the payloads and the layers, and then you have all this the signing mechanism with keys and key signing keys, a little bit like a DNSSEC. But I've never played with it, so. But good question, yeah. Yes.
Brian Cantrell from Joanne described running Docker containers in VMs like every time you do that, God will kill a puppy and something to that effect. And I was wondering what's your opinion of containers inside VMs, or whether it's we should run it on bare metal, or is it maybe it's a transition?
So my opinion about running containers inside of VM, just with the question asked earlier, I think I want both, because when I want to deploy stuff, I want to be able to deploy stuff super quickly, like I did when I did my push demo, like, okay, look, it pushes, and in 2 seconds everything is pushed. If I do the same thing with VMs, maybe if I have a really crazy ZFS machine with tons of SSDs and so on and so on, maybe I can create 5 VM images and push them to a VM image store in a few seconds. On a cheap laptop, no. So I still want containers for that kind of nimbleness, maybe. Then I also still want VMs because, well, first I can't run containers natively like that. I don't want to go to the data center. I don't want to have to deal with people going to the data center for me. So I would rather have VMs. So I still think we need both. And I know that for some people it's like, well, we're just stacking layers on top of layers on top of layers. But that's pretty much, from my humble perspective, that's pretty much the story of computer science since the 70s. It's like, at first we built something really simple, and using that simple thing we built something kind of better and more complex. And the end result is that, yeah, now when you do like a little, I don't know, let's say you use Angular or jQuery even, like to make a little calculator inside the web browser, the number of stacks that we traverse just to do 2 + 2 = 4 in a browser is insane compared to what we could do with compiling like 3 lines of C. But the difference is that now anybody can do it in the browser immediately and can create interfaces using all those stuff that we built after all those years. So I think I still want to have VMs and containers because I want to have the advantages of both. And when there will be something else like unikernels, I want to have that as well. I don't want to have to pick this or that. I just want both. Yeah.
You just mentioned unikernels, and Docker bought unikernels.
I just mentioned unikernels, yeah, so now I have to tell more about unikernels. Yeah, so we acquired Unikernel Systems, which is a team of completely crazy smart people in Cambridge. What can I say? Like, well, the Docker Mac, this thing which is in private beta, is a lot like the child of Unikernel Systems in some ways, because even though the end result is an application like that you install on a Mac, like a normal application, like in the application folder, under the hood, it's a lot of really low-level system stuff. It's a Linux VM that runs in a really weird kind of virtualization environment and that can talk to your system. It has a full TCP/IP stack for reasons that I won't develop because otherwise we'll still be there tomorrow morning. To make something that works really easily out of the box, you need a lot of really complicated things, and so that's what those people are working on right now. Down the road, we see unikernels as it's something maybe in between containers and VMs, in the sense that it's less than a VM, it's more than a container, but it doesn't mean that it will obsolete both containers and VMs. I think at some point I will have VMs, and some of those VMs will be normal Linux VMs, some of them will be unikernels. Maybe there will be a unikernel providing network or storage features for another VM or another unikernel, and so on and so on. So. No more questions? Thank you so much.